In this video, we'll be going over the trigonometric law known as the law of sines. The law of sines states that the side length A divided by the sine value of the angle directly across from it, which will be designated by a capital A, is equal to the side length B divided by the sine value of the angle directly across from it, capital B, which is equal to C divided by, you guessed it, the sine value of the angle directly across from it, designated by a capital C. Now there are two scenarios where the law of sines can be used to solve a triangle. First, if you have two angles and any side length. This is designated as AAS or ASA, which stands for angle angle side and angle side angle. Recall that if you have two angles, you can take 180 degrees total for the triangle minus the two angles to get the third angle. The second scenario is when you have two sides and an angle opposite to one of them. In this case, we have a angle and the length directly across from that, which is A, and a side length B. This is known as a SSA or side-side angle form. Now let's take a moment to prove that the law of sines works. To do so, we must use our knowledge of right triangles and SOHCAHTOA. If we take the triangle and put a line that connects one corner to the other side at a 90-degree angle, we get two right triangles as depicted. Recall that the sine of an angle equals the opposite side over the hypotenuse or longest side of the triangle. In this example, we have the height or side H, which is the opposite side of the angle A and B. Then we have the side length B and the side length A as the hypotenuse of these two right triangles. Plugging that into the sine of an angle equals opposite divided by hypotenuse formula, we get the displayed equation. Rearranging these formulas, we get that B sine of A angle equals the height, and A sine of B angle is equal to the height, or H. So being the same height is used between both formulas, height must equal height. This means we can set the two equations equal to one another. Rearranging those formulas, we have that A length over the sine of A angle equals B length over the sine of B angle, or in other words, the law of sines. You can also flip all of the numerators and denominators in the law of sines to get another form of the law of sines. Now let's do an example where we are given an angle B, which is 28.7, A length, which is 43.06, and a C angle, which is 102.3. Take a minute and pause here to try and solve the problem for yourself. So first, we must use our knowledge that this is an angle side angle triangle, so we can use the law of sines on this triangle. Next, we can take the 180 degrees of all of the angles in the triangle added up and subtract our C and B angle to get A. We're left with an A angle of 49 degrees. Make sure you have your calculator in degrees and not radians. Now we can plug in our A length, our A angle, and our B angle into the law of sines formula and solve for B. Rearranging the formula to get B to one side and using the calculator, we get a B length of 27.4. Now doing the same process of plugging in our A length and our A angle and our C angle and rearranging the formula, we get a C length of 55.75. Now let's work on the side-side angle triangles. This is a triangle where you are given an angle, the side length of that angle, and another side length of that triangle. There are a few different cases for these side-side angle triangles. It can have no possible solutions, one possible solution, or two possible solutions. If A is acute or less than 90 degrees and the A length or length opposite of the given angle is less than the height of the triangle, there is no possible solution. Next, if A is acute and the height equals A or side length opposite of the angle, then we have a right triangle and there is one solution. If A is acute and the A length is greater than B, the other length given, there is one solution and the triangle will look something like this. If A angle is acute and the other side length given, B, is greater than the A length and A length is greater than the height, or H, there are two possible solutions, listed on this slide as length A1 or A2. Your triangle could look like either of these triangles with A1 or A2 completing the triangle. If A angle across from the side length given is obtuse or larger than 90 degrees and is less than or equal to B, there is no possible triangles. Now if A angle is obtuse and the length is greater than B side length, there is one solution to this triangle. Now let's do an example problem where we have a side-side angle triangle, which again is a triangle we can use the law of sines on. The triangle has an angle of 20.5 degrees and a length of 12 and a B length of 31. We want to solve this triangle. You may want to pause here and take a minute to try to solve it for yourself. Let's look back one slide. We notice that in this case there will be two solutions because we are given an acute angle and the B length is greater than the A length, which is greater than the height or h of the triangle. So we'll be solving for two triangles that look like these. So now let's first solve for the angle at B1 when it looks like a triangle that looks like this. Using the law of sines and plugging in the A angle and A length and B length and rearranging it to get what we are solving for, B1 to one side, we get that the inverse sine of 31 times sine of 20.5 over 12 equals B1, which equals 64.8 degrees. Now for the second variation, we notice that it is really a triangle with the right triangle right of the height line in the first example removed from it. So B1 angle and B2 angle made up like this. So this means we can take the straight line angle of 180 degrees minus B1 to get B2 angle, which in this case is 115.2 degrees. Using the rule that all angles in a triangle equal 180 added up and the law of sines, we get the displayed solved triangle. You might want to pause here for a minute to take it in. That concludes this video. Hopefully I've earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well. Thank you for watching.